Let's take a look at a quick example. Let's evaluate the line integral over this curve of xy ds, where this curve C is parameterized as x equals t squared, y equals 2t, from t goes from 0 to 1. So looking at the pieces that I'm going to need, first of all, f of xy equals xy in this case, which is going to be equal to t squared times 2t, which is 2t cubed. Dx dt equals 2t. dy dt simply equals 2. So now I can take a look at this integral. This is going to be the integral from 0 to 1 of 2t cubed times the square root of 2t squared plus 2 squared dt, which both these 2's are squared, so I'm just going to factor it out. And I'm going to get 4 times the integral from 0 to 1 of t cubed times the square root of t squared plus 1 dt. Now to integrate this, I'm going to do u substitution. So I'm going to let u equal t squared plus 1. Then notice here that u minus 1 is equal to t squared. But that also implied that du is equal to 2t dt. So what I'm going to do is this 2t, I'm going to use up a 2 from the 4 and one of these t's and end up with the t squared left. And I'm going to take that t squared and I'm simply going to write it in terms of u. So that's going to end up giving me then 2 times the integral of u minus 1 times the square root of u du. Now, I don't have to here, but I think I will. Go ahead and actually change variables. I did a u substitution. Normally, we just integrate this and then transform back to t's. But I think I'm just going to go ahead, because this looks so straightforward, and do a complete change of variable. So if u equals t squared plus 1, when t equals 0, u will equal 1. When t equals 1, 1 squared plus 1 is 2. I'll get u equals 2. So this integral will be from 1 to 2. Now I can go ahead and just simply leave this as u's and not worry about going back to t's. So this is going to give me 2 times the integral of, remember this is u to the 1/2. So this is going to be u to the 3/2 minus u to the 1/2 du. So now it's set up so I can nicely and easily integrate this. So this could be 2 times u to the 5/2 divided by 5/2, which is 2 over 5, minus u to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. I think I'm going to factor out these 2's and get a 4 out here. So this is going to be, 4 times the integral u to the 5/2 over 5 minus u to the 3/2 over 3. And this I'm going to evaluate from 1 to 2. It's going to end up with 4 times, 2 to the 5/2 over 5 minus 2 to the 3/2 over 3 minus 1/5 minus 1/3. There's just some arithmetic to be done here. So this is going to be, 4 times u to the 5th. That's going to be, 2 to the 5th, square root of that. So I can pull out a 4 out of that and get 4 root 2 over 5 minus 1/5. So this would be just minus 1 over 5 right there. And then this one, I'm going to have 2 cubed, so that's going to be 2 root 2 And this is going to be plus 1, because of the double negative, over 3. And I'm going to leave that as a subtraction here. Okay, so now let's find the common denominator. I really should just let you finish it from here. It's just a bunch of arithmetic. Let's see, this is going to be 12 root 2 minus 3 minus 10 root 2 plus 5 over 15, which is 4 times 2 root 2 plus 2 over 15. So that's what, 8/15 times root 2 plus 1. And that's the way I would submit my final answer for that.